Hello and welcome everybody. Welcome back to another webinar in our filtration webinar series. And it's great to have you back. We're up to episode number 5. So without any ado whatsoever, I'll begin to share my screen and we'll get straight into that. So by way of introduction again, my name is Paul Marley. I'm the Technical Training Manager from HYTALK in Australia. We are in the middle of a webinar series, and that series is on oil filtration. So we have finished suction filtration last time. So we're up to number 5, pressure filtration. So the idea with this presentation is we're going to be looking at what is pressure filtration, advantages, disadvantages of that, and some extra things about bypasses and indicators that are used in filters. Now, again, of course, if you have any questions, put them in the questions tab. We can address that at the end. And if you are interested, that we're going to have a poll at the end of this as well. And we're just going to simply ask a question. But please put your questions in the questions tab, and that way we'll see them and we can address them at the end. Okay, so as I said, this is about pressure filtration. So what is pressure filtration? It is basically when we have the filter placed in the delivery line. So if you have a pressurized system, that's sometimes seen as the pressurized line, of course, and that's why we call it pressure filtration. So basically this is fitted after the pump. Now that then could also mean that that filter could be placed anywhere within that pressurized system. So it's not necessarily placed after the pump. That's a very, very common place to put it. But you could have subsequent filters in the system. So this is even filtration in lines to the actuators, where you have flow going in both directions. And there's options to do that. But it is less common because it's pretty clear that with an actuator, whether it be a cylinder or a motor, you're going to have flow going in both directions. But there's ways around that. There's filters that will filter in one direction and bypass in the other direction. But basically, what I'm saying is there's many places in a pressurized system that you can put these filters. Advantages of using pressure filtration. Well, there's a very clear principal advantage, and that is because unlike suction filtration, where you have the risk of cavitating the pump, when you have pressure filtration, you can go fine. So fine filtration means ultimately that you're going to be able to have good cleanliness levels achieved without damaging anything. So you can do the fine filtration with the fine media. You have pressure available to push that oil through the media. So for those reasons, it works very well. And ultimately, if you consider that the reason we have the filtration in the first place is because we want to have as clean a fluid as possible, then this answers that question. It's a very, very common way of making sure that you have good cleanliness levels. You can also have a targeted protection as well. If you have very sensitive components, say you have a sensitive valve, a servo valve or a proportional valve or something like that, there's also an opportunity where you can put a filter directly in line before that component. And one neat way of doing that is having a filter that has an interface that is suited to industrial valve interfaces. So NG6 CTOP 3 or NG10 CTOP 5. So you can see there's an image here. This is called a DFZ. And the DFZ is seen sometimes as a last chance filter. That's the term that it gets used, called sometimes. And it's because, you know, after your main filtration, your principal filtration has occurred, then anything that's gotten through that, you know, this is going to be protecting that very sensitive and sometimes very expensive component. So there's just another way that this pressure filtration is applied. Now, there are some downsides to placing the filter in a highly pressurized line. Pretty commonly, of course, it's going to be in a hydraulic system, a high pressure. So as a consequence of that, the filter needs to be robust. It needs to have a heavy construction. And this means that you have an extra cost then in the materials in both the element and the housing. So you have then a very expensive solution. Okay, so it's more expensive than other forms that we're going to be looking at. So that's a downside. It's going to cost you more. Another downside is, of course, if you have a large filter element with a very heavy construction bowl, it's going to be very heavy physically. So sometimes these are difficult and unpleasant to replace, particularly if somebody's put these in a pretty dodgy place. Yeah, there's some downsides there, but generally the advantages outweigh the disadvantages very clearly. Okay, so let's have a look at these filters and how they work in a little bit more detail. I want to bring up a topic here that we're going to talk about all the way through this, particularly when it comes up to sizing the elements down towards the end of our webinar series, and that is element delta P, pressure drop, and filter bypasses. That delta P is a very important thing. So I thought at this point I'd clarify what this is about. So what is a differential pressure? Well, a differential pressure is that you have, in the case of flow, for example, before a restriction, you're going to have a higher pressure before the restriction and a lower pressure after the restriction. So the difference between those two pressures is the pressure loss across the restriction. So sometimes you'll call that a pressure differential. It's the difference between two pressures. Pressures measured at two different points, the difference between them. So the expression is, in engineering language, using the Greek letter D for delta. So delta P in symbology, delta P is sometimes written, and of course dP is sometimes written as well. So they are absolutely the same thing. Okay, so that's with regards to a restriction. Now, with regards to a filter is restrictive. So it's exactly the same thing that's going to occur. So in this case, if you have a delta P, it will be the difference between pressure at point A and pressure at point B. So as I said, delta P is one of the most important fundamentals in filter technology, and it is important to understand. So hopefully I'm making that clear. Now, I want to also emphasize that there's a difference between the delta P pressure and, of course, the working pressure. So the working pressure in the system, the maximum expected working pressure, can be quite high. Some of our filters are rated to 420 bar, but the differential pressure is always a lot lower than that. But with pressure filtration, you have pressure at point A and point B. So you need to be able to measure those 2 points. So delta P, or pressure drop, is affected by the filter's media, so how restrictive the element is. Okay, so a finer filter will have a higher differential pressure. The filter's surface area, the physical size of the filter element and the housing. Okay, the larger the filter, the lower the differential pressure will be. The fluid's flow rate has a very clear effect on what the differential pressure will be. The fluid's viscosity, okay, so that is, definitely going to have an effect, and that's influenced by temperature. The fluid's density will change the differential pressure, and the loading of contamination that is caught by and held within the filter media. So essentially, pressure differential will rise over time. Now, you're going to get changes in all of those things, but what we're really trying to measure here is what our loading is with regards to contamination, so that we know when to replace the element. Filter elements can only take a finite pressure differential before they collapse. And when they collapse, everything that they've caught will be released into the system all at once. And that can be catastrophic for the system. Okay, so we don't want filters to collapse. What we want to have is them catch the contaminants and not be given an opportunity to release them again. Right? So ultimately then we need to make sure that that filter is going to stay intact. So we have to limit the differential pressure across the element. So we call this collapse stability, just by way of the principal HYTALK ranges for pressure filtration. A standard filter will take a 20 bar differential across it before any deformation. And a high collapse element is 210 bar. Okay, so for those into PSI, that's 3000 PSI across the element. Okay, that's not the pressure of the housing, that's the differential pressure. So these are quite substantial elements. And in a moment, I'll show you where it might be used. So we don't want the element to collapse. It is bad. So as a consequence of that, often we fit what's called a filter bypass. So the filter bypass is going to allow the fluid to bypass through the housing around the filter without having to go through the filter. And this is primarily going to be used in times of high viscosity, cold starts, or if someone forgets to change that filter element. So a bypass will prevent the element from collapsing by limiting the delta P across the filter element. So typically in a bog standard pressure filtration product from HYTALK, that's going to be 6 bar. That's your typical one, although other bypass pressures are available upon request. Not having a bypass will increase your level of system protection. However, in these cases, the high collapse element should be selected. Okay, so if you really never want to let a contamination through, then you're going to not want to fit a bypass because the filter may bypass it in cold start conditions and so on. So again, I'll bring up this DFZ filter. This last chance targeted protection is a filter that is not available with a bypass. And the reason is you never want that to let any contaminants through. You don't want the possibility of that. Okay, so for that reason, we don't want to have an element rated to 20 bar. We want an element rated to 210 bar. Okay, so that's the technology there with the high collapse and the standard elements and what a bypass is. Okay, final subject for today, filter indicators. So a filter indicator is basically going to be monitoring what the pressure differential is across the element. So it does that by measuring the pressure before the element. In the case of the HYTALK pressure filter range, it's going to be filtering through the element from the outside to the inside. So we take a reading of the pressure from the outside, so channel up here to where the indicator is, and after the element in the middle of the core, there's also another opening. These 2 points are sealed with an O-ring, and this is therefore going to be telling us, or it's going to be reading what the pressure differential is across the element. So that's how it's established. So that's going to be our watchdog. So the filter indicator helps you avoid bypass by telling you the optimum time to change the element. So for the best service life and the lowest cost of filtration, you actually want to change on indication, not on a time base. Because you change it on a time base, change your element that is, what can happen is, of course, you can replace it too late, in which case you've been bypassing and you have not been filtering. Or you can change it too early, and that's very, very common. If you change it too early, you're replacing that filter for no reason whatsoever. Okay, so you've just got basically increased maintenance costs. So it's best to have an indicator. So the indicator is typically 5 bar on a HYTALK pressure filter range. Okay, bear in mind, of course, the bypass from the standard one was 6 bar. So there's a clear window there of indication before bypass. So the bypass can be visual, electrical, with a switch point that gives you a signal when it's time to change it, or an electrical analog. And the electrical analog is, of course, going to tell you what the differential pressure is. So you can read that on a machine interface and make some decisions from there. Okay, so we have a photo here of a typical pressure filter housing with a visual indicator. Okay, so visual indicators are very, very common. I would suggest, though, that they are only really useful if someone's watching. If someone's looking at that thing, they can tell the state of it, and that's really what it's for. But if no one's there, because this filter's on a vehicle that's moving, there's no one there watching it, then maybe you need an electrical indication, and that's going to tell you something you can't see. Okay, so that's a better form of monitoring, more common. So visual indicators are fine if someone's watching. Now, the simplest indicator is, of course, a visual indicator, and then there's many, many options for indicators, and it's actually quite impressive the amount of different types of filters available with this brand, HYTALK. There's a new type of filter indicator that's been released, and this is one that is really towards the Industry 4 technologies. So this one predicts the remaining element life. And these are made for industrial and for mobile applications. Industrial applications would use IO-Link, and mobile applications would use the CAN open protocols. So these are typical digital protocols that can talk to the machine These are intelligent filters, and the indicator is really optimizing the intelligence of the filter. It has an algorithm, and it can predict what the expected life will be by looking at the trend and where it's going. And it will tell you then how many hours you have left. So rather than you get to a point where it says it's time to change, this tells you it will be time to change when. And you can make more informed decisions through that. So these are very exciting products, but they're part of a filtration solution. Okay, so you need to have excellent elements, you need to have excellent quality indicators, and you have basically then a chance of having clean oil and low maintenance costs. So I'd just like to remind you that we have 6 more of these to go in our filtration series. So, collect a set, that'd be lovely. Treat them like Pokemon. The next subject is return filtration, and that will be in a few weeks' time. So I'd like to thank everybody for joining in, and please continue to engage with us in our social media as well. So click like, click subscribe, and do all that stuff. We're in all the social media platforms, and we're trying to help you with understanding the technologies. So I would like to thank you very much for your continued attendance. It's fantastic to see that there's a clear interest in what we're talking about here. So I would like to see you next time. As I said, return filtration is the next subject. Thank you very much for attending today, and enjoy the rest of your day.